Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are doing well. This is the second class or second lecture on chemical bonding. In the first class, we have already discussed about the definition of chemical bond, types of chemical bond, and also the details discussion on ionic bond. In today's class, we will discuss about the covalent bond mainly with their examples and bond formation. Okay. So, covalent bond is a chemical bond which is formed between the two non-metallic atoms through sharing the unpaired electrons of the same elements of the same elements or different elements. Okay. For example, Cl2 molecule, right? Cl2 molecule formation. Okay. So chlorine, atomic number is 17. So electronic configuration will be 1:2, 2:2, 2p6, 3:2 and 3p5. 1:2, 2:2, 2p6, 3:2, 3px, 3py and 3pz. Dear students, you know that P is a subshell having 3 orbitals. Which are they? Px, Py and Pz. So, P subshell has 3 orbitals, Px, Py and Pz. Now, in this 3p orbital, 3p subshell, total electrons number is 5 and we have to distribute this 5 number of electrons among 3 orbitals. Okay. So, 1, 2, 3 and the rule is what? Singly first. Again, we have to distribute the electrons among these 3 orbitals singly first. That means 1, 1 and 1. Okay. Then if it is done, then again it started from the first orbital like this here. Total electron is 5. So 1, 1 and 1. Then again 1. That is 1, 2, 3, 4 and then 5. So 2, 2 and 1. And this last orbit of chlorine is the valency shell. So this is what valency shell, and total electron number in this valency shell is 7 and total unpaired electron, that means single electron number is 1. So valency is 1. So in case of non-metallic atom, the number of unpaired electron present in the valency shell will show its valency. So the valency of chlorine atom or element is 1. Now we have to draw the diagram, that is dot diagram and orbit diagram. So first is dot diagram, chlorine. This is chlorine. Total electron number is 7, 2, 4, 6. 2, 4, 6 and it is 1. Like this, here is star mark for this unpaired. Now another chlorine atom, 2, 4, 6 and it has another unpaired dot. So this unpaired of this chlorine atom and another unpaired from another chlorine atom will make a covalent bond, and that is chlorine bond chlorine. It means a covalent bond indicates a pair of electron. Again, a covalent bond indicates a pair of electron that is formed by sharing. Again, that pair of electron is formed by sharing through non-metallic atoms of the same elements or different elements. Here we have shown the atoms of the same element chlorine. Now in the valency shell, you can observe that 2, 4 and 6. These are non-bonded electron, that is lone pair electron, which are present in the valency shell of chlorine. You must draw this electron because covalent bond is happening or chemical bond is happening here in the outermost shell. So sharing is happening in the outermost shell, and you have to show the electron number which are present in the valence shell. So this is the simple dot diagram of your chlorine molecule. Now orbit diagram. Orbit diagram. Orbit diagram. Chlorine Cl, this Cl forward indicating the nucleus, and here one unpaired, and another chlorine atom has another unpaired, that becomes paired, and here chlorine, one chlorine has these 3 pairs of electron, 1 2 and what 3 as lone pair, 1 2 and what 3. So here total lone pair electron, total lone pair electrons, lone pair electrons in the Cl2 molecules. That means in Cl2 molecules, total lone pair electron number is what? 1 2 3 4 5 6. Total is what? 6 pairs. And here single bond, so total bond paired electron equal to 1 pair. It's a very simple explanation. Now we have to explain about the two rules, that is octet rule and duet rule. To get the stability of the molecule, they may follow some rules, that is octet rule. Obtaining 8 number of electrons, again obtaining 8 number of electrons by electron donation, receiving or sharing. Again by electron donation, receiving or sharing is known as what? Octet rule. So look at the board everyone. 2, 4, 6 and 8. Again 2, 4, 6 and 8. So this Cl2 molecule follows the octet rule. So we will write the definition of this octet rule. Octet rule. Octet rule. Obtaining 8 number of electrons by electron donation or receiving or sharing in the valence shell of the atom during the formation of a molecule is called octet rule. So 8 number of electrons should be present by after donation, receiving or sharing. Actually donation or receiving concept is present in ionic bond. So we can explain this in the diagram in ionic bond. Okay, I will explain it, but it is not mandatory. Again, it is not mandatory to follow the octet rule to form a compound. So it is not mandatory to follow the octet rule to form a compound. It may follow the octet rule or may not. Okay. So this is your octet rule. Now duet rule. Duet rule. It is mainly for explaining the covalent bond. Duet rule is mainly for explaining covalent bond. Okay. So here duet means two. So obtaining two number of electrons through electron sharing during a covalent bond formation is called duet rule. Duet rule. So duet rule indicates obtaining two number of electrons. Look at here, my dear students. So here duet rule indicates the two number of electrons obtaining to form a covalent bond, and it is very simple that every covalent bond is formed by two electrons. Again, every covalent bond is formed by two electrons. It means every covalent bond is following the duet rule. Every covalent bond is following duet rule. Okay. Now we can do the example. Okay. For example, PCl3, NCl3, nitrogen atomic number is 7, 1 is 2, 2 is 2, 2p3. You know, so 1 is 2, 2 is 2, 2px, 2py, 2pz, 1, 1 and 1. And in this electronic configuration, we can see that nitrogen atom has total orbit 2. So this is its valency shell. So valency electron is 5, valency is 3. Total number is valency electron, that is 5. Number of unpaired is 3, so valency is 3. Now we have to draw the electronic configuration of your chlorine atom. Okay, so chlorine, you know, its atomic number is 17. 1 is 2, 2 is 2, 2p6, 3 is 2, 3p5. So 1 is 2, 2 is 2, 2p6, 3 is 2, 3px, 3py and 3pz. So distribute these 5 electrons among these 3 orbitals. 1, 2, 3, 4 and 5. So 2, 2 and 1. Now total valence electron is here 7, 2, 4, 6 and 1, 7. And number of unpaired is 1, so valence is 1. My dear students, look at here. Valency of nitrogen is 3, but valence electron is 5. Chlorine, valence electron is 7, valency is 1. Now go to the phosphorus. 1 is 2, 2 is 2, 2p6, 3 is 2 and 3p3. Three px, 3py, 3pz. 1, 1 and 1. So total number of electron in the valency shell, valence electron is 5, valency is 3 at normal state of phosphorus. Phosphorus has variable valency and we will also discuss it, my dear student. Wait a minute. Okay. So from this electronic configuration, we can easily observe that valence of nitrogen is 3, valence of chlorine is 1, and phosphorus is what? 3. Actually, we must show this electronic configuration in our exam paper if explanation or bond formation is required in your question paper. Okay. Now, we'll draw the diagram for NCl3. For NCl3, draw diagram. So nitrogen in the valency shell total was 5. So 1, 2, and 3. These are the 3 ampere, and here 1 is lone pair. If you forget, then I am writing here again 1 is 2, 2 is 2, 2px1, 2py1, 2pz1. So these were the electrons, valence electrons of nitrogen. 3 are remaining as single and 1 as a pair. Always keep in your mind that the unpaired will be paired. Unpaired will be paired. And every chlorine atom has 1 unpaired and 3 lone pair. Okay. If you want to recall that, I can draw that electronic configuration again here. 1 is 2, 2 is 2, 2 is 6, 3 is 2, 3px2, 3py2, 3p1, z1. It was the electronic configuration of your chlorine. So 1 is unpaired. So that 1 unpaired will be paired like this: chlorine, here chlorine, 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 chlorine. So here chlorine share is unpaired with the unpaired of nitrogen. Similarly, another chlorine share is unpaired with the unpaired of nitrogen, and here the lone pair electrons which are not participating in the bond formation. So this is the chlorine. Okay. Now, my dear student, look at here. This is bonded pair, this is bonded pair, this is bonded pair. So here 3 number of covalent bonds are forming like this, like this, like this. Okay. My dear student, look at here. This is your structure of NCl3, that is orbit dot diagram. Now try to understand the number of electrons, lone pair and bond pair. And here total bond pair is 1, 2, and 3. So total bond pair, total bond pair, total bond pair equal to 3 pairs, right? Total lone pair 1, 2, 3. Every chlorine atom has 3 lone pairs. Here 3, 6, and here 3, 9, and here the nitrogen is another 1. So total lone pair equal to 10 pairs. Okay. Now, is it following octet rule? Of course. How? Here is 2, here is 2, and here is 2, and here is 2. When we evaluate the octet rule following, then we have to calculate the total number of electrons surrounding the central atom. Surrounding the central atom, and which is central atom and which is lateral atom? The atom having the maximum valency will be known as central atom. The atom having the lower valency will be the lateral atom. Here the valency of nitrogen is 3, so it will be the central atom, and here chlorine is valency is 1, so it will be the lateral atom. So surrounding this central atom, we have to count the total electron numbers, including lone pair and bond pair. Again I am saying including lone pair and bond pair. Okay. So 2, 2, and 2 and another 2. This is bond pair, bond pair, bond pair, and one is lone pair here. So total is 8. It means it follows octet rule. So follows octet rule, and of course duet rule also. Why? Because I have already said that to form a covalent bond, two electrons is required, and this 2 means duet. So this is a covalent bond, this is a covalent bond, this is a covalent bond. Every covalent bond is made by 2 number of electrons, that means they are following duet rule. So of course every covalent bond is formed by 2 electrons and they are following duet rule. So follows what rule? Duet rule. So this is the simple structure of your NCl3 or orbit diagram. Now similarly we can explain the PCl3. Okay, I will make it PCl3 with a very much short technique through cleaning the nitrogen part. Look at here, that's very much easy, and most of the informations are similar between this NCl3 and PCl3. Okay, now draw here phosphorus. Draw here what? Phosphorus. And phosphorus has 5 number of electrons in the valency shell, and 3 is unpaired. 1, 2, and 3 is unpaired. Now from chlorine, 1 unpaired will come, then becomes paired, and here will be paired, and here will be paired. Similarly, sharing in nitrogen. Okay, and lone pair of phosphorus is 1 pair. So now counting is similar like nitrogen. What counting? Lone pair and bond pair. Look at here, total bond pair is 1, 2, and 3, similar to the NCl3, and total lone pair is 3, 6, 9, and 1, 10. So total lone pair is 10. Follows octet rule because here total number of electrons is what? 8, and also follows what rule? Duet rule. Okay, so these are the diagram of your PCl3. Now my dear student, we'll see PCl5, PCl5, PCl3, and what? PCl5. This already we have drawn the diagram of PCl3. Now we will draw the diagram of PCl5. First, we have to understand that phosphorus atom has 3d orbital, but this is present in empty condition at normal state. So why 3d is present? You know that s orbital starts from first orbit, p orbital starts from second orbit, and d orbital starts from third orbit. So when electron enter into the third orbit, it means third orbit has 3 subshells, that is s, p, and d, that is 3s, 3p, 3d. For example, in a third orbit, electron enter into the only 3s orbital according to our Auber principle, but 3p and 3d will be present. Electron may be entered into that orbital or not. But when the electron enters into the third orbit or third energy level, of course, in that third energy level always present 3s, 3p, and 3d. Okay. If required, then we have to write that. Okay. Now at excited condition, one electron, that is symbolized by these termers, will be jumped from 3s orbital to 3d orbital. That means in the valency shell, if any empty orbital is present, then electron can jump from the paired orbital to the empty orbital. Again, if the valency shell has empty orbital, and in that valency shell, if in another orbital pair of electron is present, then electron can jump from paired orbital to empty orbital. Okay. So now here total number of electron is present as similar, that is 5, but the number of unpaired is now 5, that is valency is 5. So very simple, phosphorus having this 5 number of unpaired, 1, 2, 3, 4 and what 5, and 5 number of chlorine atoms will participate like this, chlorine like this, like this, like this, and here also. Dear students, look at here. Here every chlorine atom supply a single electron to the phosphorus atom and bonded with the unpaired of phosphorus atom. So here 5 covalent bonds will be formed. Okay. So they will make what? PCl5. Now my question is to the octet rule and duet rule. Okay, look at here. How many electrons are present surrounding the central atom phosphorus? Look at here. My dear student, there is no lone pair surrounding phosphorus. There is no lone pair surrounding phosphorus, but lone pair surrounding chlorine. So it is very good MCQ question that is there any lone pair surrounding phosphorus atom in the structure of PCl5? Answer is no. But in case of PCl3, of course, there is a lone pair surrounding phosphorus, and that is one pair. But in phosphorus of PCl5, there is no lone pair surrounding phosphorus, but there is lone pair surrounding chlorine. Okay. Now we have to evaluate that follows octet rule or not. 1, 2, 3, 4 and 5. Total 5 pairs, that is bond pairs. Total 5 pairs means 10 electrons, so it is more than 8. If electron is more than 8 surrounding the central atom and a molecule, that is octet expansion. It means deviated from octet rule, that means octet rule is not followed by that compound. So this is PCl5 does not follow octet rule, but follows duet rule. Okay, my dear student. So between these two structures, PCl3 and what? PCl5, we can easily say that PCl3 follows octet rule and duet rule both, but PCl5 follows duet rule but not octet rule. I think you will understand everything about this. Now we will discuss about the variable valency of these two molecules. Okay. Now PCl3, PCl5. Okay. Look at here. Look at here, my dear student. Here active valency. Active valency means the valency which is actually present in a molecule of an element. For example, here the active valency of phosphorus is 3 and here it is 5. So active valency, here phosphorus is 3 and here is 5. You know that if an element has more than one valency, then its valency is called what? Variable valency. So here valency of phosphorus is variable valency. So what is the definition of your variable valency? If an element has more than one valency, then its valency is called what? Variable valency. Now, what is latent valency? Latent valency. The formula of latent valency is maximum valency minus active valency. Look at here, my dear student. Latent valency equal to maximum valency, here V for valency, minus active valency. So, in this PCl3 molecule, the active valency of phosphorus is 3. Active valency of phosphorus is 3. And you know that between these two molecules, or we know that the variable valency of phosphorus are 3 and 5. So between this 3 and 5, maximum value is 5. So maximum valency of phosphorus is 5. So here latent valency is 2. So in PCl3 molecule, latent valency is 2 because maximum valency is 5 and active valency is here 3. So latent valency is 2. Similarly, in PCl5, maximum valency minus active valency. Maximum valency is 5 and here active is also 5. So it is what? 0. So latent valency value can be 0 if it is minus from the highest valency to the active valency. Okay. Now, this is the explanation of your what? Latent valency and active valency and active valency in a molecule. Okay. Now, you can do that example for another molecule also. Okay. So now we'll discuss the next points. That is H2O formation, NH3 formation. H2O, in H2O you know that oxygen is present like this, 1s2, 2s2, 2p4, 1s2, 2s2, 2px, 2py and 2pz. 1, 2, 3 and 4, that is 2, 1, 1. This is the valency shell. So valency electron is 2, 4, 5, 6. Number of unpaired is 2, so valency is 2. And you know that the electronic configuration is hydrogen is 1s1, so its valency and valency electron both is 1. Okay. Now you can draw the diagram of this water molecule. Okay. Now oxygen having the 2 unpaired, 1, 2, but having 2 pairs as lone pair, and we have already said that the unpaired becomes paired. Hydrogen has unpaired, hydrogen has 1 unpaired, that will be paired with your unpaired of oxygen. So this is the dot diagram. This is the dot diagram, and here these 2 covalent bonds will be formed. Now look at here, 2, 4, 6, 8 follows octet rule. Total LP equal to 1, 2, 2 pairs. Total BP, that means bond pair, is 2 pairs. And another information is that follows octet and duet. Okay. Now we can draw the orbit diagram of your H2O. So oxygen last orbit, 2 unpaired, and that becomes paired with your hydrogen, like this. This is hydrogen and this is what? Hydrogen. Now these are the lone pairs. So this is the orbit diagram of your water molecule. So this H2O molecule follows octet rule, duet rule. Number of lone pair is total 2 pairs, total bond pair is 2 pairs. That's it for H2O molecule. Now NH3. NH3. Okay. Nitrogen 1s2, 2s2, 2px1, 2py1, 2pz1. So total number of electrons here 5. Valence electron is 5. Valence is what? 3. So nitrogen 3 ampere, 1, 2 and 3, and this 3 amperes will be paired with the 3 number of hydrogen atoms like this. So here total electron number is also 8, 2, 4, 6, 8, including lone pair and bond pair. So it also follows what rule? Octet rule, and duet both. Now if you draw the orbit diagram like this, last orbit 1, 2, 3, this unpaired becomes paired, this unpaired becomes paired with hydrogen, and with what? Hydrogen, like this. So this is the orbit diagram of your NH3. Now we'll discuss the last diagrams or structure of covalent molecules for today's class, that is CO2, CH4. Firstly CH4, then we'll draw CO2. Okay. CH4, you know, carbon electronic configuration is this: 1s2, 2s2, 2p2, 1s2, 2s2, 2px1, 2py1, 2pz0 at normal state. But at excited state of carbon, 1s2, 2s1, 2px1, 2py1 and 2pz1. The total number of unpaired is 4. So valency electron is here 4 and valency is also 4, and hydrogen, you know that is 1s1. So if we draw the orbit diagram, dot diagram, then carbon is 1, 2, 3 and 4, and 4 number of hydrogen atoms with their unpaired electrons will come here like this, and they will make 4 number of what? Covalent bonds, and we will get CH4. This is the dot diagram, and finally the orbit diagram will be like this: 1, 2, 3 and 1, 4, like this. My dear students, you have to practice this diagrams by yourself through the writing. You can use the pencil or compass if it is required for the better structure. So this is the another diagram of your CH4, that is orbit diagram. Now the final diagram of CO2 of this class. CO2, you know, carbon at excited state 1s2, 2s1, 2px1, 2py1, 2p what? Z1. And oxygen is what? 1s2, 2s2, 2px, 2py, 2pz, 2, 1 and 1. So valency electron for carbon, valency electron is 4, valency is 4. For oxygen, valency electron is 6, valency is what? 2. 2, 4, 5 and 6 is valency electron, number of unpaired is 2. Now orbit diagram, 1, 2, 3, 4. 4 is unpaired. An oxygen has 2 unpaired like this, another oxygen has 2 unpaired like this, and one oxygen has 2 lone pairs, that is like this. 2 pairs as what? Lone pairs, and here 2 pairs as lone pairs. So this is double covalent bond, another side, and another opposite side, another 2 covalent bonds are formed like this way, double bond this way. Now these are the dot diagram of what? CO2 molecule. Now finally we have to draw the orbit diagram. Carbon, the last shell, 4 number of electrons like this, 1, 2, 3 and 4. They becomes paired with what? Oxygen atom like this. Okay, so this is oxygen, this is nucleus of oxygen, and 2 pairs as lone pair. 2 pairs as what? Lone pairs. Now my dear student, look at here for counting the lone pair number of electrons, and bond pair number of electrons here, 1 pair, 2 pairs, 3 pairs, 4 pairs. So total BP means bond pair is 1, 2, 3, 4, 4 pairs, and total lone pair 1, 2, 3, 4. Total LP is also 4 pairs. Okay. Now we have to count the total number of electrons for evaluating octet rule following or not. So here total number of electrons, here is 4 and here is another 4. So total is what? 8. So follows octet rule. Follows octet and duet. Why? Because here every covalent bond, we know that every covalent bond is made by 2 number of electrons, that is duet number of electrons. So they are following what rule? Duet rule. So I think so these diagrams and structure, electronic configuration, everything will make you help to understand the covalent bond for the students reading in SSC level and O levels also. Inshallah, we'll discuss in details for the rest of the topic related to this bond with their bond angles and the rest of the types of chemical bond, inshallah, in our next videos. To try to connect with our Chemistry Unlock channel and subscribe and press the bell icon for the updates, inshallah. Okay, Assalamu alaikum.